number was this? This is number, I believe it was number 4. So this is number 5 here. It says rank these substances in order of increasing solubility here. Okay. So I want most soluble to least soluble. So most soluble to least. And I'm giving four options here. So I have the first guy here is CH3. CH3. CH2. And there's a 5 here, and then OH. I have a CH3. CH2, 3, and then an OH. And then I'm going to look at the right side here. I have CH3, CH2, CH2, OH. And then finally a CH3, CH2, OH. And that's going to which one is the most soluble, which is to the least soluble. I'm going to rank these guys here. So let me give them numberings here. So I have 1, 2, 3, and 4. So as I look at these compounds here, I have an alkane group here. All of these guys here are alkanes. Sorry, all alkanes here. So straight chain alkanes, which is great. And then I have a hydroxyl group, right? These guys are here alcohol groups. So all of these guys here are alcohols because they are, I see the hydroxyl groups, and we all have alkanes. So basically when we're talking about solubility, we care about the intermolecular forces that exist in these compounds here. So as you can see, since they're all alcohols, they all have hydrogen bonding, right? Because of the hydroxyl, the hydrogen on hydroxyl groups can make the hydrogen bondings with our oxygen atoms in solution here. So hydrogen bonding exists. We also have a dipole-dipole, right? Because the electronegativity difference between carbon and oxygen exists, right? So we have a large difference of electronegativity. So therefore, there's a partial positive on this carbon here. So you can say that this carbon has a partial positive. This oxygen has a partial negative. It's pulling electron density away from it, which is great. And then obviously we have London dispersion. So keeping these guys in mind, what do we care about here? So all these guys affect solubility, right? So if we look at hydrogen bonding and dipole-dipole forces, all of these guys have hydrogen bonding and dipole-dipole forces, right? Again, we all have hydroxyl groups, and they all have the electronegativity difference between the carbon and the oxygen. So these two guys are good because we have all of them have everything. But the London dispersion forces vary between all these guys here. And the reason why is that London dispersion here is the weakest here, right? And number 4 here has the weakest London dispersion forces. And number 1 here has the largest. The reason why is that it has a longer alkane chain. This one has a 5 chain, right? So this one has the strongest LD forces. And as we know that, because we know that this one has the weakest LD forces, this has the strongest one. This one here is particularly more hydrophobic, right? Because alkane chains are non-polar. So these guys here are all non-polar. So let me do that. Here, these guys are non-polar. And this end, the hydroxyl end, is obviously the polar end, and that's the point that's soluble, right? So if you want to label these guys here, which one's the most soluble? Well, number 4 is the most soluble here. So the most soluble is number 4 because it has the weakest. You can say it has the shortest alkane chain, so it's less hydrophobic. So this one would be 4. It would go 4, 3, 2, and 1. So this here is the order from most soluble to least soluble, and this here is our solution for this problem. And again, the longer the alkane chain here, the more nonpolar the molecule is going to be, because again, it's pulling electron the difference here away from our hydroxyl group here. So the carbon is becoming more and more important, more positive. You can think of it that way. So again, it's 4, 3, 2, and 1 here. So again, it says here solubility depends on like dissolved like, which is good. So we have here, therefore, butanol is much alike to water molecule than hexanol. Butanol is more soluble than hexanol. So as you can see here, it's 4. So ethanol is the most soluble here, and then it's propanol, and this here is butanol, and this here is a hexanol here. So this solution here is correct. And again, I think they have the first, or actually they mixed up these two actually. So the person who submitted this mixed both of these up, and they didn't actually talk about the solution as well. So this solution is partially correct because they didn't figure out the other guys here. Most soluble to least soluble. So it would be ethanol, propanol, butanol, and hexanol. All of the compounds have a hydroxyl group. However, the longer the alkyl chain, the more nonpolar the compound becomes, making it less soluble in water. Therefore, ethanol is the most soluble, while hexanol is the least soluble in water. So the solution is partially correct because they only answered the first two. So in this case, I'm going to say incorrect because they're missing some information here.